Hello, this is the Department of Nuclear and Quantum Engineering of KAIST. There is a growing interest in spent fuel management. We have created materials to find out what we need to learn from the status of spent fuel management in the world. Today, we would like to visit Sweden, country of Vikings and Nobel Prize. Sweden has the most nuclear power plants in Northern Europe. They currently produce about 40% of the electricity from 10 nuclear power plants. The remaining 50% is hydropower, and the fossil-fueled power generation rate is as low as 5%. It is one of the lowest countries in the world, with 47 grams per kilowatt-hour of carbon dioxide emitted from electricity generation. Korea is using 60% of fossil fuel in electricity generation, therefore, we have 10 times more carbon dioxide emission than Sweden, because coal is emitting at 990 grams and natural gas is emitting 550 grams per kilowatt-hour. Let's look at how Swedish storage system differs from dry storage in Switzerland. Sweden has been operating a spent fuel interim storage facility since 1985. They have a wet storage facility that is located in rock caves 30 meters of underground and stores spent fuel in water pools. The fact that all spent fuel is stored in one wet storage facility is unique in Sweden. Currently, about 6,500 tons of spent fuel is stored in the water pool. They can store up to 11,000 tons of all spent fuel from Sweden in the future. Most spent fuel in Korea is stored in the storage pool in the power plant. 10 meters of water can shield the radioactivity, and the cooling system keeps the water temperature below 40 degrees. When spent fuel is stored for 10 years, the radioactivity and decay heat are reduced to about 1/100th to 1,000th. Then, transportation, storage and disposal of spent fuel become very easy. Will it be safe to store spent fuel in a wet storage facility? Before the Fukushima Daiichi accident, there was a wet storage facility that stored more than 6,000 assemblies of spent nuclear fuel. Many people worried that a hydrogen explosion would occur if the coolant leaked or evaporated. However, the wet storage facility has not been damaged despite earthquakes, tsunamis and hydrogen explosions, proving its safety. After the Fukushima accident, US NRC reassessed the safety and security of wet storage. It was because there was a lot of opinion that the wet storage was dangerous and the spent fuel should be moved to dry casks. As a result of re-evaluation of terrorism, earthquake, leakage and fire accident, US NRC confirmed that both wet storage and dry storage are safe enough. As shown in the photo, the spent fuel storage facility has a concrete wall thickness of 1 meter or more and has a seismic-resistant design equivalent to that of nuclear reactor building. Sweden is a leading country in the disposal technology of spent fuel. Finland is known as the most advanced country in the construction of deep geological repositories. Finland has already been approved for repository construction in 2015 and started construction of a repository 450 meters underground in Olkiluoto site in 2016. The deep geological repository technology used by Finland is developed by Sweden. The spent fuel will be sealed in a corrosion-resistant copper canister in a 500-meter deep 1.9 billion-year-old granite tunnel. The tunnel will be filled with bentonite clay that absorbs water and prevents radionuclide migration. The safety of the repository has been confirmed by the regulatory agency last year, and they are in the process of being reviewed by the Land and Environmental Court. Sweden has selected Forsmark as the repository site in 2009 after studying geology, groundwater and ecology of Forsmark site and Oskarshamn site since 2002. The most important basis for the repository selection was geological safety, in addition to the approval by 77% of residents. There is a claim that the costs of disposing of spent fuel are not taken into consideration, but are transferred to the next generation. How is Sweden doing? It is said that it earns about 0.02 kronor per kilowatt hour. It's about 3 Korean won. Let's compare it with the Korea case. Spent Fuel Management Fund in Korea, which is 320 million won per nuclear fuel assembly, is 2 won per kilowatt hour, assuming that the fuel assembly produces 16 megawatts of electricity. Also, considering that one assembly produces electricity worth 110 billion won, it can be seen that the cost of spent fuel management will be only 3% of electricity price. In the Forsmark area, nuclear power plants are in operation with a medium and low-level repository. Nevertheless, 77% of respondents favored hosting a spent fuel repository. How could it be possible? Waste Management Agency SKB says it has conducted more than 10,000 conversations with residents in the area where 20,000 people live. This is a good example showing that a shortcut that enables safe disposal is only the trust that builds up through persistent and truthful communication with residents. So far, we have studied the status of spent fuel management in Sweden. In order to safely coexist with our spent fuel and to pass on a safer future, it seems that we need to learn from the Swedish people who have prepared the spent fuel management technology in cooperation with the local people. Thank you for listening.